The AnchorMake 3D printer has been described as an ultra-fast machine that just works. Today we're going to put that to the test. AnchorMake sent me out a brand new $399 M5C. And today we're going to put it to the test with the weirdest filaments that I could find, like iron impregnated, copper laden, and even wood. I tried making my own 3D printer filament out of real gold, but it didn't work. We almost had everything figured out. We had the high torque motor, an auger where the pellets go in and get extruded out of the hot end with a heatsink and a fan. We were super close, but not good enough to put gold inside. Apparently, making your own filament is a much more complicated science than we anticipated. However, my loss is your gain since now we have $500 worth of this gold dust that we can give away at the end of the video, after we finish testing out the rest of these filaments. Let's get started. I've been tinkering with 3D printers for like the last 10 years, and the hardest part with all of my previous machines has been the setup. With this new AnchorMake M5C though, within 10 minutes we're ready to start printing. The gantry fits right down into the aluminum die-cast base, which helps keep the machine stable as the all-metal print head zips around at super high speeds. And this printer has some ridiculously high speeds. Here at my shop, we've been prototyping inexpensive manual rigid wheelchairs. And instead of paying thousands of dollars early on for plastic end cap molds for the aluminum tubes, we just 3D print them for pennies. Extremely helpful and efficient as we fine-tune our design. The AnchorMake M5C moves at 500 millimeters a second and accelerates at 5,000, 80% faster than other 3D printers on the market. Seeing the printer move in real time is mind-boggling. Speed is important for us because every second and every penny counts when we're trying to save money and time making inexpensive prototypes. Speaking of pennies, let's see what happens when we feed the M5C with copper impregnated filament. If we take a look at the copper under a digital microscope, we can see that it looks quite a bit more textured and shiny than a normal plastic filament. Little fragments of metal in there. We'll have to oxidize it later to differentiate between the materials. We'll make a Statue of Liberty. Starting a new 3D print is incredibly easy. I can take a 3D model, slice the G-code to a USB stick, and with one singular button, get a three-dimensional shape turned into reality. This also works with the mobile app, and I'll show that more in a second. As you might already know, the real Statue of Liberty over in New York City is made from copper. Copper is usually a nice reddish brown color. However, when it's exposed to the outside elements and oxidizes, the outer layer turns a nice shade of green, which is the current color of Lady Liberty as we know her today. If we take some normal table salt and dissolve it in vinegar and spritz it on her to speed up the oxidation of the metals inside the filament, we can make that oxidation happen a little bit quicker. Looking at the 3D print through a microscope before the oxidation, we can see that the print is extremely accurate. AnchorMake says the M5C is to precise within 0.1 millimeters. And just like a normal 3D printer, the nozzles are interchangeable depending on how thick or exact you want your layers. That is crazy. I had my doubts, but that copper is hardcore oxidized. That is amazing. And jumping in to take a look at that oxidation. Wow. Looks almost bluish under the microscope. But that's definitely green on Lady Liberty. And there you have it. Real copper inside of 3D printing filament. Oxidizing right where the salt comes in contact with the layers. Things have changed quite a lot in the last few years, and this is extremely impressive for a $399 printer. Taking a look at the iron. Wow. Trying out the iron impregnated filament, I never thought I'd have to use slow motion footage to show off a 3D printer, but if we slow it down to a speed that the human eye can see, we can see the molten filament leaving the metal nozzle, making contact with the print, and through some pretty complex algorithms, the fans rapidly cool it to just the right temperature, so it sticks to the print without warping or making spaghetti. Personally, I leave on the 49-point self-auto-leveling feature, just as an extra safety factor to make sure the print doesn't fail. And the 300 degrees Celsius hot end works great for PLA, TPU, PETG, ABS, PA, and PC, making this printer pretty COOL. Taking a look at the iron impregnated filament, we can see once again that the print is very clean, even with metal inside. And after we oxidize it with the same vinegar and salt concoction, this is surprisingly heavy, probably because it has metal in it, we can see the metal is definitely behaving differently than the plastic it's embedded in. A very difficult filament to print with, and the AnchorMake 5C is handling it just fine.
So cool.
The copper definitely looks cooler than the iron. Very impressive. Now for 3D printing with wood. Again, just like the copper and iron filament, the wood coming out of our hot end makes up about 20 or 30% of the filament, enough to be sanded and stained like wood, and also enough to smell like freshly cut sawdust, as it's making our box to store the gold dust, which once again is printing out surprisingly fast. With the print finish, we can magnetically pop off the printing plate and get our real, genuine 14 karat gold dust situated within the container for safekeeping. The AnchorMake M5C does have a singular start and pause button on the front surface, but no display. All of the controlling for the printer happens within the mobile app or from your computer. And there you have it, a 3D printed wooden box with real gold inside, a treasure chest if you will. I'll be giving this away. It's worth about $500 to someone in the comments. Leave any comment about anything and I'll pick a random winner in a few days. And the final verdict is the AnchorMake M5C is a super inexpensive, ultra-fast 3D printer that just works and can handle some really weird stuff. I'll leave a link down in the description if you want to grab one for yourself, and thanks a ton for watching. I'll see you around.
Oh, the pain, agony.
So that should be good.
Oh, but the shot looks so good.
Okay. And now we're ready to print.